Hello and welcome to another module of Advanced R. In this module, we are going to discuss about several aspects of building an R package. Here, we will show you what are the different steps to build up a package. By now, you might have come across a number of packages which will indeed help you to do all the calculations, all the data handlings and something like that. Here exactly we are giving you some steps, all the steps basically we will give you all the steps by which following which you can build up your own package, and it will indeed be helpful for you and for others as well. So, let us see what is there in this module. So, we are starting with the question that do you like to create your own package? Obviously, you do, because R provides us lots of things which are very useful and lots of easier ways to make your own package. So, why not use this? So, let us start with this. For this, a big thank to those people who have contributed a lot to make the necessary tools and documentations for that. So, here we have some statistics. As per the records of July 2013, there are 4714 packages on CRAN and another 671 on bioconductor. So, there are huge amounts of packages in R. In the past, building a package was much more complicated, but it's no longer complicated now and it's very easy nowadays. A famous package is Hadley Wickham's DEV tools package. So, before getting into the main point, it is important to know about the folder structure that you should know in order to build your own package. So, here are some of the aspects of a R folder. An R package is actually a folder of folders. So, let us see what is there within a folder. Each folder contains specific files. There must be at least 2 folders. The folder R is the place where the included functions go, and the next man is the place where the documentation files are kept. At first, all the documentations were done manually, but things are easier now, things are simpler now. Roxygen 2 has eased the process. You can say it R oxygen 2 or Roxygen. You can pronounce it in both the ways. So, R oxygen 2 is a CRAN package. You may click on the link which we have provided here to know more about this R oxygen 2 package. Each file of the folder must end with a blank line, and the code that we have used that must be shorter than 105 characters. So, these are some technical issues which you need to remember. Now, there are some other folders, other common folders which are src, data, inst and so on. This will give you things which are given here. Now, when a package is installed, these files are not human readable, though there are some of the exceptions of this case when you can have all these files, you can identify all these files and you can read all these files. Now, all packages submitted to CRAN or bioconductor must follow some specific guidelines, including the folder structure of the package, inclusion of description and namespace files and proper help files. So, there should be uniformity in order to do this. Now, the question is, what does your package do? So, these should be incorporated within that. Here are some of the issues like title. It is a one-line description of the package. It is often noticed in package listing. You might have come across all these things, but it might be the case that you haven't noticed all these things, but all of us have seen such kinds of things. And then the characteristics, it should be plain text, no markup, it should be capitalized like a title, it should not end in a period and should be short. And the other thing is listings, it often truncates the title to 65 characters. So, this is the upper bound of this. Now, here is a description, it is more detailed than the title. We can write multiple sentences, but we are limited to one paragraph. Each line must be no more than 80 characters wide. So, these are all about some technical issues which we need to remember all the times we want to make our own package, we want to build our own package. Now, there are few steps to build an R package under Windows. The following are some of the steps. In step 1, you need to update R and other tools. Then you need to know your Windows system, the system you are using. Then you need to decide what kind of package you want to build. Next, you need to get the necessary tools, and after getting them, you need to install them. Next, you need to fix the path, then reboot and do some study with that. Then you need to look at the sample package. Then if required, you can edit some files, and finally you can build the package. So, after 10 steps, after the 10th step, you can finally building your own package. So, here we are having some detailed discussion regarding all these 10 steps. So, firstly we are taking up the discussion of update R and other tools. First, update the version of R to the current version. Here I will, it is always recommended to use RStudio instead of R, as I have told you earlier as well. RStudio is easily available. It includes various options like source editor enhancements, options for customizing pen layout and appearance, and all these kinds of things that have been given here. So, it is always recommended to use RStudio in this purpose. And the next step is know your Windows system, that is the system you are using. You should know about your Windows system, especially when you are coming from a different platform like Mac. So, get familiar with three of the things which are location of your R program, R console and path. Here my path is given to be like this. Now, next here comes the idea of choice of package. Two kinds of packages that are there are packages where the source is R code and packages where you have code in C or Fortran or C++. You have come across packages of these two kinds very often. This choice makes you determine what kind of package you need. Then you can also determine which tool you need. In fact, to build packages that include only R source, you do need any of the compiler tools that is given here. The tools are related to documentations, and if you want to build packages that have source code in a language other than R, you need the compiler tools. So, for C, C++, you need to have the compiler tools. If you want to build packages that only contain R source code, then you do not need the compilers, as everything is there within your system. Next, we will be discussing about building packages that have only R source code. So, first you need a program which will create the help files for your package. Now, here which I recommend you to use MikTeX for making this, and MikTeX is available at here. So, you can download that always. Then you need a program for making HTML help files. Microsoft Help Workshop can guide you to download and install the appropriate tool. Then here is a URL for that. The last tool you require is Art Tools, and with this URL. Each time whenever you are downloading any tools, take some time to read the documentation here. Now here comes some of the ideas of installing the tools. You can install MikTeX for all users and select it later. During this procedure, take care for missing elements. I recommend you to install to the default directory it offered, which is this. If necessary, you can modify your path available. While installing HTML tool, it may require you to create a HTML help workshop folder. So don't worry and proceed and install these things. And the path is this, which is given here. So the next thing is how you can fix your own path. Go to your path variable and cut and paste it into a text editor. If you make any mistakes, you can revert. So there are always rooms to modify this. There are two important things to remember. The first one is you have to fix a path to rcmd.exe, and here RCMD is remote command service, and here is the specification of it. You may receive one or more of the following errors using this, and the errors will be like the one we have given here. Next, on my system it's on this path which is given here, and make sure you have fixed your path. Also, you need to add a path for Windows HTML help workshop. Fix the path for our tools. Now here comes some of the ideas of rebooting. After fixing your path, take some time to read some documentations. Write or edit some documentation files to build the package, then check properly. Now why do you need to read the documentation? Because you must get familiar with the documents produced by the tools. You can go to this tool and get details about building our package. So these are all some kinds of mechanical things which you need to follow in order to build your own package. Pay attention to the section on creating RD files. These files are the source files which are used to create R manuals and also help to make documentation for your package. You may always have come across some of the documentations when you are wanting to know the details of some of the packages. Now this process will create several files, so edit immediately, otherwise package will not be built. Edit the documentations corresponding to the packages. So check properly, otherwise it might give some other indications. So check it properly, and to do so spend some time with the documents. Now here you need to note that sometimes it is hard to understand what your documents will look like when you are editing them in the RD format. So it's always suggested to look for any tool that will give you a better option for editing and creating them. Now here comes the idea, the final idea of creating a sample package. Before creating sample package, create a new directory from your working directory. Start your R session and change your working directory to the new directory you have created just now. So here is some of the things to create that. You may use setwd, getwd, and then using the require stats package, you can always build these functions like f, g, and then you may use these functions as well. The next thing is you need to give these many codes for this which have been given here. Now, when you will execute this, it will give you the things which is given here, and the further steps are described in the link which I have given to you. Now, the question is, what is package.skeleton function? Package.skeleton sets up for a new source package which creates directories, saves functions, data and R code files to appropriate places, and creates skeleton, help files, and a read and delete me file describing further sets of packaging. So, you need to check that the files were created and use RStudio to get a look at the read and delete me files. So, now you need to have a look at the read and delete me files, edit the help file skeletons in man, possibly combining help files for multiple functions. Then you need to edit the exports in namespace and add necessary inputs. Then you need to put any C or C++ or Fortran code in SHC. Now, if you have compiled code, add a use this function directive to namespace. Then run our CMD build to build the package tarball, and then you need to do this which have been given here. So, now here comes some of the ideas of editing files. Some basic ideas on how to edit the files in RStudio. If you want to know that, then first look at the description file. Here is what the description file tells you. This is the name of the package which have been given name as my package, then type, this is a package, then the title, then the version, then the date, then the author name, then the maintainer name, then the description, and finally it is the license. Then after editing the description file, you have these kinds of, you might have these kinds of things. Next, fill in your own information, and please look at the documentation guide for specific rules to write documentation. And in the next slide, we will edit some of other files, some of the other files, and we will start with the package description. So, here are some basic ideas of building package in R, and we will continue the description of this in the next module. So, in the next module, I will edit some of the other files. So, from this module, we have come across a number of ways to build up your own package. These are indeed very helpful and very easy as well. Previously, it was not that easy to build up your own package, but nowadays, with the help of some other dependencies, it's indeed very helpful. We have come across a number of examples showing some particular packages in order to show how this making a package is useful to us. We will continue this discussion in the next module as well. So, let us stop here and let us see what is there in our next module.